Right, so we would have I've just burned that cracker. I've stunk up my room with the smell of burning cracker. But it's a really good intro to this. So, we're looking at the energy content of food. There's all kind of weird and wonderful ways they've done this. But really, we're going to just be looking at the energy that's given when we combust them or react them. You'll look at solution colorimetry, bomb colorimetry, and some graphs. But it's all kind of based on this very simple experiment that I did. So what we're using is our specific heat capacity to work out the energy that's released. And then once we've got that figure, we can work out per gram of food that we've got. So I've got my figures here. So I started at... I should probably annotate that for you. So my energy, this is my mass of water. The C is my specific heat capacity of water. And my delta T is the change in temperature. So I need these three things to work out the energy that was released, and then per cracker I would find this energy. This could probably be used in conjunction with our values that we used last time. So I could look on the back of the cracker and know that it's this much protein and this much fibre and this much carbohydrates, and that's my actual, but this is another way of doing it. And you might want to think about how you would compare what you got, what the packet says, theoretical, actual, all that kind of stuff. So first we need to do some kind of fudging of the numbers, some massaging of the numbers before we put them in here. No, not even massaging, some using the numbers. Right, so we've got 38 was my final and 22 was my end. And because I've learnt that I can't be trusted doing simple maths at night time, I'm going to do that. So 16 is my delta T, my change in temperature. The mass of the H2O in my data. So, notice how much we're using our lovely data book and how nice it is they give us. So at 25, I mean we were at 22, so slightly different, but you know, close enough for to be able to use it. For each milliliters I have, it's going to be 0.997 grams. So I had 100 milliliters. Therefore, I have 100 times 0.997. 99.7 grams. That's how much water I had. So I can put all of these in here. I've given myself more to here. I've given myself no room. So my energy. So my mass of the water is 99.7. That's times by my specific heat capacity, which is here. 4.18 times delta T, which is 16. And I'm using my calculator because I am not ashamed to say that maths in my head, despite having a degree, is not my strong suit. 67.937. joules. So that's my energy given off, which for the whole cracker. But I want to know per gram of cracker because, well, you might want to know That can't be right. Okay, so that's how many joules of energy I have. Oh, kilojoules, that's what I'm thinking. 6 kilojoules. Yeah, that seems about right. Give or take. So that's a good thing to think about. Does the number seem normal? Have you made a mistake? Does it seem too ginormous? Joules doesn't. Kilojoules would seem huge. If that was 6 kilojoules, that would be far too much. Right. So I want to know per cracker, per gram of cracker, so then I can compare cracker to cracker. So there might be different sizes, might be different, masses. So I've got 3 grams per cracker. The scales at home aren't very accurate, so that could be anything from 2.5 to 3.4, but we'll go with the 3 grams. So all I have to do is take this. That seems to me, oh, I keep forgetting to move and check I'm doing the right thing. That seems to me the easiest way to think about our significant figures is to convert it to kilojoules. Or I suppose you could do the scientific notation, but that to me seems that's perfectly fine unless they say something in the question about doing it in joules. But I've seen both, so I don't know why you wouldn't do that. So that's a very simple student experiment. This might be the kind of thing you could see in that last question. What could we have done better? So we had that terrible situation. There was no insulation, there was no lid, I was moving the cracker around, I probably didn't burn all the cracker the same, like there was a bit where I was holding it and the tongs. So when you're watching these experiments, whether it's mine or whether it's one of the ones online, keep considering those little improvements, those little things that they didn't do that they could do to improve it, because that's going to be those little things that are going to help you in the exam. And be specific. Don't just say, oh, insulate it, put a shield around it, put a lid on it. Specifics are going to get you the marks. So that's how we work out the energy of a cracker.